Okay, we did one example of calculating the variance and then the standard deviation of a data set. I wanted to take a look at another one, so we get a little more practice with this methodology, but also to let us take a look at another way you might go about getting at variance that doesn't necessarily rely on you getting a mean first. It's not a big adjustment, but anyway. Um, all right, so the PowerPoint slides feature two different data sets. In a classroom setting, I usually use them as like a basis for comparison. I'm going to focus on this particular set of values because it's a little more interesting to look at. And if you're wanting to play around with the second one, I've left you the easier one. You're welcome. Anyway, so if we look at these values, first order of business, we need our data set's mean. Feel free to check me on this. The mean for these data values is in fact 12. All right, so following through on our process from before, we subtract our mean from each one of these values. So unlike the last time where we had all those awkward decimals floating around, yeah, this works out kind of nicely. -6, -5, -4, 0, 4, 5, 6. Now we got to square each of these guys. Remember, squaring gets rid of the negatives here. So if you're working through one of these and you have minus signs in this column, something gone wrong. Go back and do it again. So this time around, again, thanks to sort of the symmetry that's built into this, we have an even stronger symmetry with those numbers right there. Awesome. So those are our values. Just as a quick heads up, when you're doing this, if you are just like punching this into a calculator, I'd recommend using like the parentheses keys to enclose like -6 squared, because if you just type like -6 squared like that, the way the calculator interprets its operations, it actually does the squaring of 6 first and then puts the negative on it. That's usually where minus signs end up showing up here. So yeah, if you were putting it into like a TI-83, it would look like that. So to make sure you actually get the operation performed correctly. Anyway, so now that we've got all of these values worked out, we sum them up. When I add them all together, I get 154. Remember, our process now says we divide by one fewer than our number of data values. If you count those guys up, there are 7 of them, so I need to divide this by 6 to get my variance. That is not a convenient, decimal or anything. It rounds off to 25. It was 25.666666666, on my calculator display, so I just rounded it to one decimal place. So that's my variance. The standard deviation, as we said last time, is the square root of that guy. So variance, standard deviation. So when I worked that out, I got approximately 12.4. So there, that's that done. All right, so that's one way you can go about calculating variance and then getting standard deviation from it. So if you've looked ahead in the slides a bit, you've seen there's something labeled alternatively. There's another method that you can use that sort of gets around having to calculate the mean, and it also usually gets you out of having to worry about negative values here. But so let me clean this board up real quick, and then we'll take a look at that process. All right. As it turns out, this one doesn't quite need as much real estate in terms of what you would do with generating a table. So we've still got our data values here. We don't actually need the mean at all for this one, which is kind of wild given what standard deviation is supposed to do for us. So here's what we're going to do. We square each of these numbers, and then we add them up. So when I square these, those I remember from just my old multiplication tables. If you need a calculator, that's fine. I don't judge. 16 squared I know because it's a power of 2, and I needed to do that stuff when I was learning computer programming. Anyway, these last two, yeah, I put them into my calculator. I don't have these committed to memory. But so 36, 49, 64, 144, 256, 289, 324. All right, now I need to add these guys up. So I'm going to put sort of a total column under here. So, yeah. When I added all of those guys up, I got 1,162. Okay. So that's step 1. Square these, add them up. Next, we sum up all of these values and then square. Well, for what it's worth, We kind of had to sum those up when we were looking up our calculating our mean for the last one. We get 84. When I square that, I would get 7,056. All right. Now from here, I'm kind of just going to keep layering the steps of the process on top of each other. If you wanted to work out individual values, you can. It's fine. So now I take this number and I divide it by the number of data values I have. Not one less for the moment, just the number of values. So I take the 7,056, I divide by 7. Technically, that would give me 1,008. That's fine. All right. Now I take that and I subtract it from this guy right here. So I have 1162 minus 7,056 divided by 7. Okay, you got that? All right. So from here, when I do that subtraction, like I said, this would give me 1,008. 1162 minus 1008. That number should look familiar. We get 154. So yeah, from here, we're essentially at the same place we were at in our variance calculation via the other method. Now, I divide that 154 by one fewer than my data values. So I got the 25.7 to get my standard deviation. I take my square root, and I get 12.4 again. So I like going through both methods. One, to demonstrate, the more different ways you can do something and get the same result, the more likely it is you're on the right track. Also, this gives you sort of two different ways of looking at this. So if it turns out you're not so comfortable with the subtractions and the minus signs and you're bad about forgetting to square negatives, this method gets around that particular difficulty. So for what it's worth, I don't require you to know both methods. My recommendation to you at this point would be pick whichever scheme you feel more comfortable with and just run with it. So come test time, I'm not going to ask you to demonstrate calculating the variance via both methods. So long as you know one, you are good. All right, so we've talked so far about calculating variance and then calculating standard deviation. That's great. We've got a fair number of examples under our belt. You've got another data set in the slides you can look at. You could revisit the test scores from the previous video using this method if you want to. You've got ways to practice this. You might end up asking yourself at this point, though, self, this is a pretty long process. What is it actually getting us? What does it tell us about the data set from which we're getting this value? I think I'll leave that for another video.